Let's talk about state functions again. What's interesting about them is, first of all, they're path independent. And the second thing is it really doesn't matter whether you're talking about length, mass, volume, moles, all these different things that we talk about with state functions. In thermodynamics, we're totally concerned with energy change. Changing from state A to state B, what did the energy do? Not just what did the number of moles do and what did the substances do, but what happened to the energy? How is the energy different now? And so in thermo, we bring in some new state functions that you don't often think about matter having. It's pretty easy to look at a glass of water and go, yes, that has mass. I can see it clearly. It's 500 grams of water or a certain volume of water. Temperature is even very apparent to most of us. But most of us don't look at a glass of water and go, by golly, I can tell that that has this many kilojoules of enthalpy. Or, wow, that's got that much entropy in it. It's got this many joules per degree K. That, though, is a state function. All these new guys in thermodynamics, and I'll name them: internal energy, which we give the symbol E; enthalpy, we give the symbol H; entropy, symbol S; and free energy, the symbol G. All of those are different forms of energy that we quantify, and every single one of them is a state function. Meaning, as matter just sits there doing absolutely nothing, it has a specific value of internal energy, free energy, entropy, and enthalpy. It has all those as it sits there. We just don't have a nice probe to stick into it and measure it. That's the complicated thing about thermodynamics. We can't just tell you that's got this many kilojoules of enthalpy. But what we can do is we can allow that to change from one temperature to another. And in that change, the delta T reveals what the change in delta H is. So we can calculate delta H real easily just by knowing what delta T was. So by measuring certain state function changes, we can get at the change in these thermodynamic state functions. Once again, that's the importance of state functions. And in thermo, we're concerned with all these four new ones. So pay attention to them and you're going to see them over and over throughout thermodynamics.